All right, so let's walk through an example of using retrieval augmented generation to do that same thing we did with fine-tuning earlier, to actually recreate the character of Data from Star Trek, only this time through cheating. So again, the high-level approach here is that we're going to parse all of the scripts from every episode of The Next Generation to extract every line that Data ever said in the TV show. Very much like we did in the fine-tuning example. The difference, though, is that we're not going to take into account the context of who Data was talking to. We're just going to extract his individual lines, because we're just going to be searching against them here. After that, we're going to use the OpenAI Embeddings API to compute embedding vectors for every one of those lines, and then we'll shove those all into a vector database. And to keep things simple, we're going to use something called VectorDB, which just runs locally in your little environment here. So rather than making you go sign up for yet another cloud service and yet another cloud-based database, we're just going to do this locally using VectorDB. Obviously, in the real world, you might want to use something more robust. Once we do that, we're going to make a little retrieval function for RAG, and its job will be to retrieve the n most similar lines from the vector database for a given query. So when we're going to ask Data a question, I'm going to go hit that vector database to retrieve the most relevant lines of dialogue associated with that query. Once I get those back, I'm just going to add them as context into the prompt before I hand that off to chat completions to get back an answer from OpenAI. A quick note here about LangChain. So a lot of the examples you see for retrieval augmented generation use a higher level framework called LangChain, and it's pretty popular right now. I'm not using it here, A, because I don't know if it's going to stand the test of time or not, but B, you don't really need it. I mean, this is not complicated stuff. So yes, LangChain might save you a few lines of code here, but not enough to be worthwhile. I think it's more important to understand how to do this from scratch to understand what's going on. All right, so let's dive in. So before we do this, there's a couple of bits of housekeeping we need to do. First of all, later on, we're going to need to actually retrieve those script files. So to do that, I need to go to my file section here in Colab. And by the way, I do recommend using Colab for this, mostly because VectorDB has a lot of weird dependencies. And something like Anaconda locally, you're probably going to run into installation problems with it. Even Colab has trouble with it, but it works at least for now. Anyway, let's upload those script files before we forget. Open up the sample data here under your files, and we're going to create a new folder. New folder. And we're going to call that TNG for the next generation. And there, we're going to upload our scripts. Now, just a reminder where to get them. Let me cancel out of this. So there's a little handy dandy link here. I can't include this with the course because it's copyrighted, but you know, if you want to go and get these, I can't stop you, right? So you want to look for the all TNG episodes archive here. That's what we're using. And again, you could use this with any TV show or movie that you like. I mean, most scripts are pretty similar in format. But I already did that, so I'm going to go ahead and upload those into my new TNG folder. So let's say upload, and I'll navigate to where I downloaded that to. Scripts TNG, and I'm just going to select everything here and throw it in. So we're going, yeah, I know they're not going to last. But let's wait for that to upload. Meanwhile, the other thing we need to do is put our OpenAI secret key in here so we can access that as well, because we're going to be using the OpenAI API to generate embedding vectors and also to do our chat completions. So under the little secrets tab here, what I want you to do is say that your notebook access should be on. You want to give it a name of OpenAI underscore API underscore key, and then paste in your secret key from OpenAI. And if you need to go get that from your OpenAI account, go take care of that first. All right, that's all we need to do to prepare. So let's go back to our files here. Looks like those are all uploaded. Cool, we're ready to rock and roll. All right, so let's get started. First thing we're going to do is install the VectorDB package. So go ahead and shift enter on that, just pip install VectorDB. And if you're doing that the first time, that will probably take several minutes. So go ahead and pause this video and come back when you're done. All right, as promised, that took a few minutes, and there are some scary looking errors. They should be safe to ignore though. Moving on. So let's start by parsing out those scripts and extracting the data that we need. This is very, very similar to the code that we looked at in our fine-tuning exercise, so I'm not going to spend a lot of time on it. But again, at a high level, all we're trying to do is find the lines of dialogue that Data said. And the raw script files here are in kind of an unfriendly format. So you tend to see that the format is basically, you'll see a line of text that has a single all caps name in it. We're going to use that as a signal that somebody's about to say something and who's about to say it. So essentially, I'm going through this and looking for single lines that just say data in all uppercase. Let's see if I can find one here real quick. Yeah, like data. It registers as solid, Captain, right? So all this code is going to do is go through here looking for lines that say data, and then taking the next series of lines until we see an empty line and say, okay, that's going to be that line of data, and reformat it to be, a single sentence on a single line, right? So that's all that's going on here, really. So we have all this stuff to like strip parentheses from things and test if something is a single word in all caps, which means it's probably somebody's name, and then extract those subsequent lines of dialogue until we hit a new line to get that one line of data. And here you can see where we're hard coding that we're looking specifically for data. There are more elegant ways of coding that for sure. This process directory function just goes through every single one of those files that we uploaded. These all represent an individual script from an individual TV show, and goes through each one of them and extracts everything the data ever said. And it puts all of those into an array called dialogues. So that we're going to have this array called dialogues that just contains everything data ever said in that TV show. All right, we kick that off. Let's go ahead and shift enter to get that in there. And now we're going to actually call it with the process directory call. And it shouldn't take too long. Already done. Pretty easy, right? Let's go ahead and make sure it actually worked. So let's just print out the first line of dialogue that it extracted to make sure something's there. And it is. So, the first line of dialogue in this example was Ambassador Odon, Dr. Crusher, I was just on my way to see you. And based on the order that things uploaded here, your line there might be different than mine. Don't worry about it. All right, so now let's set up our vector database. All we need to do is import what we need from it. So we need something called basedoc and also NDArray to construct basically the class that defines what a document in our vector database looks like. It's very simple for us. It's just a string, that's the line of dialogue, and the embedding vector, which is an array of however many dimensions we choose. Now, just to keep things simple and fast, I'm going to choose 128 embedding dimensions here. You could go larger, though. I believe the model we're using has up to 1,536. So you could play around with that and see if your results get better as a result. But let's stick with 128 for now. Go ahead and run that. Might take a little bit of time since it has to import some stuff for the first time here. And that's done. All right. So next thing we have to do is compute the embedding vectors for every one of those lines of dialogue before we insert it into our vector database. So let's start by installing OpenAI. That's just the OpenAI API. And that's done. Again, we should be okay with those errors. We'll find out the hard way soon. All right, so now what we're going to do is actually use the OpenAI client and say, let's make an embedding. At this point, we're just going to test and make sure that it works with a single line of dialogue here. So what I'm going to do is create the OpenAI client here. We're going to construct that using the OpenAI API key. Again, you already put that into your secrets, right? If not, go take care of that now. We'll choose our embedding model, text embedding 3 small. Over time, these models do change and get deprecated. So if that stops working for you, just use a newer model. You'll be fine. And just to see if it works, let's go ahead and create an embedding vector from the second line of dialogue that we have, whatever that is, with 128 dimensions, and using the embedding model that we specify and print out the results. Let's see what we got. It worked. Awesome. So we got back a vector, hopefully with 128 dimensions. Let's double check. Just print the length of that vector. It is indeed 128. All right, so we appear to have a means of creating embedding vectors for given lines of dialogue. Cool. So now let's do that en masse. We're going to create a new list called embeddings that contains embeddings for every single line that data ever said. And because you can only do this in a batch up to a certain point, I'm going to do this 128 lines at a time. So using a little bit of Python trickery here to say that I'm going to be going through every line of dialogue that I have, which is in the thousands, and go through it 128 lines at a time. So for every chunk of 128, I'm going to feed that to the OpenAI client and create a bunch of embeddings all at once by passing in that slice from our total array of dialogues 128 at a time. So the input here does not have to be a single line of dialogue. It can actually be an array, and that works too. So in this case, we're taking something called dialogue slice, which is just a slice of 128 lines. And we do that over and over and over again until we get through everything. And as we do that, we keep on adding the results to this embeddings list that we're building up. So let's go ahead and do that. And you might think this would be expensive and take a long time, but it doesn't. Like I said, this costs less than a penny, at least today, and you'll see it's done pretty quick, considering that it's encoding over 6,000 lines of dialogue here. So let's just wait for that to finish. And we're done, and you can see that took less than a minute. That might seem like a while, but compare that to how long it took us to fine-tune the model using that same data. That took hours, right? So you can see this is a lot faster and cheaper than fine-tuning, but you know, again, it's cheating and the results will reflect that. You know, it can't actually, it's not really building a model of how data thinks and talks per se, right? It's just going to be regurgitating these lines of dialogue that we gave it to some extent. Let's just make sure that we got back as many embeddings as we expect. How many did we get back altogether? 6,502. Hopefully that checks out for you as well. So now let's go ahead and insert those into our vector database, into VectorDB. Pretty simple to do. We do need to create a workspace directory though. So back to my sample data here, let's go ahead and create a new folder again. And I'm going to call that workspace because we need to store this vector database somewhere. So all we're going to do is say that we're going to create a new VectorDB using the in-memory exact NNV VectorDB implementation, using that directory for its files. Okay, then we just, in this one line of magic Python code, we go through every single embedding and we go ahead and insert it using dialog line with the associated line of dialogue and the associated embedding vector for that line. And we just index it when we're done. So let's kick it off. And that was unbelievably fast. I hope it really worked. We're about to find out. So let's test it out. Let's actually do a query here, and we'll query the text lol my daughter. We'll go into OpenAI and create an embedding vector for that query, and then query our database, our vector database, to get the top 10 most similar lines of dialogue to that query. So we construct a query that consists of the query text lol my daughter, the embedding vector that we got back from OpenAI, and we do a search with a limit of 10 results, and we print them out. Let's see what happens. And it worked. My gosh, it really was that fast in inserting all that data. Let's scroll up and see what we got back. All right, so the first line of dialogue that came back was the line, "That is lol my daughter," which is a pretty darn good match to lol my daughter. So that's a pretty good indication that the vector database is working as intended, that these embeddings really are positioning these lines of dialogue together based on their similarity to each other. And then we got some more stuff too. So at one point you just said lol. Well, that's not going to be terribly helpful. What do you feel, lol? Again, probably not very helpful in constructing the response. Yes, lol, I am here. Correct, lol, we are a family. I guess the underlying model might pick up something from that. No, lol, this is a flower. Maybe that's telling the model that, hey, you know, lol has trouble recognizing things. Lol used a verbal contraction. So this is giving us more and more information about Data's daughter, lol. And just to give you the backstory here, in case you don't know, which you probably don't because you're not a nerd like I am, in one episode, Data, who was an android in Star Trek: The Next Generation, constructed a daughter for himself, who was also an android. And, well, you know, things happened. Yes, Wesley, lol is my child. Apparently we know that Data talked to Wesley Crusher about it, and now we're getting something with a little bit more meat to it. Lol's creation is entirely dependent on me. I'm giving it the knowledge and skills that are stored in my brain, so on and so on. So by combining all of these different lines that are about Data's daughter, lol, maybe we can give the underlying model something to work with to give it a more relevant response when I ask it about lol. All right, moving on. So let's put it all together and actually wrap this all up. So I'm going to write a generate response function here, and its job is just to compute an embedding for any arbitrary query that's passed in. It will go and query that vector database for the 10 most similar lines, just like we did, and you might experiment with using more or less results. You know, again, you have to draw that line between relevancy, right? Too many will give you irrelevant results. Too few might not give you enough information. Balancing that is a bit of an art. And then we'll construct a new prompt that adds in those similar lines as context to try and nudge ChatGPT in the right direction using that external data. We'll then feed that augmented prompt into the chat completions API to get a response that takes that database, that vector database data into account. So we take the question, we create embeddings for it, right? We take that embedding and create a query out of it and then search the vector database for the top 10 most relevant lines of dialogue to that query. That's just what we did before. We will then extract relevant context from the search results. So I'm going to go ahead and go through every one of those matches that come back and add that to a string that's just putting each line that came back on its own unique line. And then I'm going to append that in here. So that's going into a variable called context, okay? So question is the original query. Context is the additional context I'm going to pass in as part of that query. And the prompt here that I'm going to use is Lieutenant Commander data is asked, whatever the question was that was passed in. How might data respond? Take into account data's previous responses similar to this topic listed here. And then I'll give it that list of the top 10 most relevant lines from the vector DB. Then I'll print out what that modified prompt looks like so we can look at it, send it off to chat completions, and get the response back. And just to help it out a little bit further, we'll give it a system prompt that says, you are Lieutenant Commander data from Star Trek The Next Generation. Hopefully that will give the system some cues to use the underlying knowledge that it already has about that character that it was trained on, but take this new data into account as well. And we'll print out the results that we get. All right, let's kick it off. So that's just generating the generate response function here. Let's now use it, and we can pass in a question like, tell me about your daughter Lal. All right, and so remember the prompts that we gave it, right? So we're going to give it the top 10 most relevant lines of dialogue it could come up with here. So given tell me about your daughter Lal, the vector DB came back with these lines of dialogue. This is Lal, my daughter. How do you feel? Lal, we are a family. Yes, doctor, it's an experience I know too well, but I do not know how to help her. Lal is passing into sentience. This is a difficult stage of development for her. She's not the same as other children. She is my child. Talking to Wesley. Something happened to her at school. She talked to Counselor Deanna Troy, right? So maybe the captain wants him to deactivate Lal. And it's going to put that all into the modified query here that we're seeing here. So Lieutenant Commander data is asked, tell me about your daughter Lal. How might data respond? Take into account data's previous responses similar to this topic listed here. Okay, so that's our modified prompt where we used RAG to augment that prompt with external information. And the response we get back isn't bad. So there are actually several that it gave us to choose from here. Data would likely respond to the question about his daughter Lal in a logical and straightforward manner. He would provide information. Yeah. So for example, he might say, Lal is an android constructed by myself. She was created using a positronic neural network, blah, blah, blah. Although she was designed as an advanced prototype, she is itself involved into a sentient being. So that might be picking up on the sentience bit that we fed to it. Lal has exhibited various experiences and challenges in her development. Okay, so that was definitely referred to in these lines that we gave it as well. The journey towards sentience, seeking guidance from others, such as Counselor Deanna Troy. That's definitely coming directly from the data that we gave it. So you can see it's taking that information that we gave it into account and using that to sort of augment, hence the A in RAG, the response that it would have given us back without that information. So it's made the response better. The whole point of retrieval augmented generation is to augment your model with external data that may be proprietary, that may be more recent, that the model didn't have originally. Or maybe you just want to nudge it in a certain direction based on that external database lookup. But you can see it's not complicated, right? So none of this was hard. None of it's particularly resource intensive. So you can see how this is a very attractive approach for people that want to incorporate their own data into their generative AI systems. The results can be mixed. Again, it depends a lot on the relevancy of your results. If you look at the results that we got back here, a lot of them aren't giving us a lot of information, right? Like the line that just says lol, that's not doing me any good, right? So again, it's only going to be as good as the data that you're getting back from that database. But that's an end-to-end example of using retrieval augmented generation. Again, recreating the character Lieutenant Commander data from Star Trek using AI and RAG in this instance. Is it better than fine-tuning? I'll let you be the judge. I don't think so. I think the fine-tuning results were more interesting, but again, it came at a much higher cost and it took a lot more time to do it. So sometimes you got to weigh those things off and trade things off, right?